Hi everyone. In this lesson, we'll learn a classification method using distance-based similarity, called as KNN. The first term we will talk about is similarity. Similarity is the presence of common features or appearances between two or more objects, persons, or concepts. In the picture, a woman on the left and a dog on the right are compared in terms of similarity. In this example, the similarity between the woman's hair and the dog's fur in terms of shape and color is striking. The fact that they both have eyes, a nose, and a mouth can also be included in the similarity. However, when these two images are shown to anyone, they would point out that the picture contains two living beings of different species. Therefore, although there are partial similarities, conceptual differences can sometimes take precedence. In the literature, there are numerous similarity measures, such as cosine and Jaccard, which are used to quantify the likeness between two entities based on their features or characteristics. Cosine similarity, for example, measures the cosine of the angle between two non-zero vectors in a multidimensional space, providing an understanding of their orientation rather than magnitude. Jaccard similarity, on the other hand, is based on the size of the intersection divided by the size of the union of two sets, making it particularly useful for comparing sets. Similarly, there are various distance measures like Euclidean, Manhattan, Chebyshev, and Minkowski, each offering a different way to calculate the dissimilarity or distance between points in a space. Euclidean distance, the most common metric, represents the shortest path between 2 points in a straight line. Manhattan distance, also known as taxicab or city block distance, sums the absolute differences of their coordinates, reflecting a grid-like path. Chebyshev distance measures the greatest of their absolute differences, often used in chess for the king's movement. Minkowski distance is a generalized metric that includes Euclidean and Manhattan distances as special cases. By utilizing these similarity and distance measures, we can compute how alike or different 2 points are within any given space, whether it be physical, conceptual, or abstract. This capability is fundamental in various fields such as data analysis, machine learning, and pattern recognition, where understanding the relationships between data points is crucial for tasks like clustering, classification, and anomaly detection. To understand how distance metrics can be used in measuring similarity, it is important to look at their mathematical foundations and application methods. Distance metrics determine how close or far apart two data points are by calculating the distance between them. Generally, the smaller the distance between two data points, the greater their similarity. This principle is widely used in various machine learning algorithms and data analysis methods. Here are some of the most common methods for converting distance values into similarity scores. The first one is inverse of distance. This method simply inverts the distance value. As a result, closer data points have higher similarity scores. The resulting similarity score is normalized between 0 and 1. As the distance approaches infinity, the similarity approaches 0, and vice versa. The second one is negative exponent of distance. In this method, the distance value is raised to a negative power of the number e to calculate similarity. While the convergence in this method is parallel to the previous method, the convergence speed is faster. While the idea of using distance to group similar items appeared in the 1950s, it wasn't until 1962 that this concept was formalized into a specific classification technique, known as the k-nearest neighbors algorithm. K-nearest neighbor method is still the most popular classification method using distance between data points. If you have a classification dataset and an unknown data point, You can find the class of that unknown data point by using the KNN algorithm. The KNN algorithm can be summarized in 5 steps as follows. 1. Request k-value. This value is an integer provided by the user and specifies the number of nearest neighbors to consider for classification. 2. For the unknown point, calculate the distance to each data point in the known dataset. Common distance metrics used in KNN are Euclidean distance or Manhattan distance. 3. Sort all the calculated distances in ascending order. This creates a list where the distances at the beginning are the smallest. 4. Select the top k values from the sorted distance list. These represent the k nearest neighbors of the unknown point based on the chosen distance metric. 5. Among the class labels of the k nearest neighbors, determine the most frequent class label. This dominant class is assigned as the predicted class label for the unknown point. Now let's see how the KNN algorithm works on an example. Here you can see the distribution of a two-class dataset, one red and the other yellow, in two-dimensional space, while 2 points belonging to the yellow class are clustered close to each other. 3 points belonging to the red class are located far from each other. Let's call the red ones represented disease and the yellow ones healthy. Let's say a new data point of unknown class is added to such a dataset. It can also be thought that this new dot, indicated by a question mark, is a new person arriving at the hospital. How to determine the class of the point with a question mark using the class dataset at hand? We can apply the KNN algorithm for this purpose. But let's watch how different k-values change the result. In two-class data, the k-value is generally chosen as an odd number. In this sense, k equals 1 is good to start with. When we determine the classed point closest to the question-marked point, we will find the solution for k equals 1, because the class of the closest point will be the solution we are curious about. In this example, for k equals 1, the class of the unknown point is red. If we continue with odd numbers again, k equals 3 is selected in the second try. In this case, 3 different points closest to the question-marked point are determined. In this example, 3 closest points were detected, 2 yellow and 1 red. When we decide according to the majority, our prediction will be yellow. So, our prediction, which was red when k equals 1, turned yellow for k equals 3. Finally, we will try k equals 5. This way we will use all the data. In this case, with 3 red and 2 yellow, the majority says red, so we decided on red for k equals 1, yellow for k equals 3, and finally red again for k equals 5. It paints a very inconsistent picture for this vague point. It is difficult to make the right decision in such inconsistent situations. One of the traditional problems in machine learning is making decisions about data points in border regions. We can call this challenges at the boundaries. In these cases where there is no definitive answer, each method adopts a different approach. Therefore, it is crucial for the data analyst to know when any data point is borderline. For example, when we want to classify whether a person is sick or not using the k-nearest neighbors algorithm, if there is inconsistency for different k-values, it can be interpreted as the data not being sufficient to make a clear diagnosis. In such situations, the analyst should examine the data points in the boundary regions more carefully and attempt to obtain more accurate results by using alternative methods or additional data sources. Advantages of the KNN method can be summarized in 4 items. 1. Simplicity. The KNN algorithm is very simple and easy to understand. It does not require any complex mathematical model or training phase. 2. Flexibility. It can be used for both classification and regression problems. It can be adapted to a wide variety of data types. 3. Non-parametric. KNN is a non-parametric model, meaning it does not make any assumptions about the underlying data distribution. This makes it versatile for various types of data. 4. Easy adaptation to new data. When new data arrives, it can be added to the dataset and classification can be performed without needing to retrain the model. Disadvantages of the KNN method can be summarized in 5 items. 1. Computational cost. KNN can be very slow with large datasets because it requires comparing each test instance with all training instances. This is especially costly in high-dimensional data. 2. Memory usage. KNN requires storing all training data in memory. This can lead to memory issues when working with large datasets. 3. Imbalanced datasets. If the dataset is imbalanced, meaning some classes have significantly more instances than others, KNN may struggle to classify rare classes correctly. 4. Selecting the optimum k-value. Choosing the best value for k is crucial. Small k-values can lead to overfitting, while large k-values can lead to underfitting. Techniques like cross-validation can be used to determine the optimal k-value. 5. Need for feature scaling. The KNN algorithm is sensitive to the scales of features. Therefore, feature scaling, normalization or standardization, is necessary when using features with different scales. Otherwise, some features might dominate the distance calculations over others. When considering machine learning methods, hand calculation has some advantages. For example, by doing calculations manually, you can better understand the basics of machine learning algorithms and how they work. You can also better understand the mathematical principles behind algorithms, thus creating a solid foundation when learning more complex topics. On the other hand, it can help you know how to check whether the outputs of the algorithms are correct and detect errors that may arise in the application. Although manual calculation does not seem very practical in today's applications where big data is widespread, it can still be applied in cases where success needs to be monitored very precisely. For this, a new dataset is created by randomly selecting a small section from the large dataset at hand, and controls are made in this small dataset by manual calculation. We will see how the calculation is made for different k-values with the dataset given here. A dataset containing 4 examples, 2 features and 2 classes appears on the screen. Using this dataset, we will predict which class the point -2, 2, whose class is unknown may belong to. At this point, you can pause the video and try to solve the question. You can then continue to see the steps and the result. In the question, we were asked to use Manhattan distance for ease of calculation. Calculations start by calculating the distance of the unknown point to 4 points in the dataset. The distance values are 5, 9, 5 and 3 units, respectively. Taking these distances into consideration, Class B is estimated for k equals 1 and Class A is estimated for k equals 3. Since there is an inconsistency here, it is conceivable that the point may be in border regions. Thanks for watching. We recommend that you attend class for in-class activities.